Hi, this is Stephen Brower from Raton Valley Community College. This is for CSIT 256 Computer Architecture and Assembly Language, and this is a brief overview of Stallings Chapter 11. Portions of this chapter are a repeat of Irvine Chapter 1, and then there's one portion, which I'll point out, is not in Irvine. Actually, there's more than, let's just keep going. So what we'll be looking at in the Stallings Chapter 11 are logic tables. So the use of logic tables for Boolean operators, a collection of Boolean variables with those Boolean operators to create a Boolean function. And we'll look at the ways that those can be represented, one as a table, and the other one as a combinational circuit using graphical symbols for the gates. So we'll see a graphical symbol for an AND, graphical symbol for an OR. And one of the things that will be pointed out is that all of the Boolean operators can be represented using a combination of NAND operators. And why this is important is that what some computer chip manufacturers did is by only developing NAND gates, they from only having to manufacture one gate, although the combinational circuit is a little more complex, sometimes with some multiple NAND gates, then there's the saving of cost of only having to create one gate. And so that's something that will be looked at later. We'll see a couple other things, like if we have a logic table and we need to come up with a formula, one way to come up with the formula, and we'll see the sum of products. We'll also see the product of the sums, but I'll just pick one of them for us to go through. Now the chapter goes into all kinds of ways that we can simplify a Boolean function. And it gets into things like De Morgan's Rum theorem, whatever. There's a number of mathematical processes, the postulates, etc., that can be used. But what we're going to take a look at is a sort of like a brute force approach to being able to simplify a Boolean function, and we're going to look at Carnot maps. So there's an addendum in Canvas for Carnot maps, and then the architecture lab, I forget the number, but there's an architectural lab that's going to be focusing on doing the Carnot map. Now the Boolean functions that we're going to see, you might look at it and be able to simplify it in your mind and go, well, that's it, or you can apply this postulate and simplify it. I'm like, well, that's it. But we are going to, as an exercise, apply the Carnot map. And then there's certain pieces in the representation of that I do want to see. One of the things we'll look at is the 4-to-1 multiplexer, and there's a reason for that. One of the things we're going to see in latter chapters in Stallings is the use of data, address, and control lines, and that 4-to-1 multiplexer kind of shows that, and that'll help us when we get to chapter 5 talking about memory. Or is that 4? Oh, 5 talking about memory. Another thing we're going to see are some flip-flops, and that also is something that we'll see again when we get to chapter 5 on memory. Yeah, there you go.